Hey everyone, in this video we're going to make a custom hash table class. In one of my previous videos I kind of talked about the theory of hashing and how hash tables are made with arrays. And in this one we're going to follow that up by taking some of the code we made here, such as generating a hash, creating a hash index, and actually creating that and moving it into a class. So first thing we're going to want to do is create a hashtable.py file. This will allow us to turn our code into kind of like a module or a library of sorts so that we can distribute to other people. And this is actually the second time I've done this video, because the first time I forgot to record the audio. And in the first video, I did the same exact thing. I named it HashTable. No, it's HashTable. So what we want to do here is we're going to create a class called HashTable. We're going to have it inherit from the basic object. And then we're going to create an interface for this. The first thing we need for all of our classes is a constructor. So we create that with the init declaration. And what we want to pass into this is the size of the hash table that we're going to end up creating. And we'll give it a default value of 10. Usually, if in an application you're creating a hash table, you're probably going to store more than 10 entries into it. But for the purpose of this video, we're just going to make it small, something easy to manage and conceptualize what is going on. So we're going to set that size on the class object to be the size that we pass in. We're making this an optional parameter, so if someone doesn't actually pass in a size, it'll just be assigned 10. But if they do, then it's here. Self.num elements. So this will be how many entries we've actually put into the hash table. This will help us decide if we need to resize the hash table or not. With hash tables, as you insert more elements, the chances of collisions increase. So if we put 100 elements into a hash table with size 10, then we're guaranteed at least 10 collisions, which will make the lookup time be 0.10 instead of 0.1. And for the hash table efficiency and optimalness, we want our hash table to be bigger than the number of elements in it. So as we insert more elements, we want to use some kind of rule, like if number of elements is greater than size, or if number of elements is greater than size times 2, or something else, then we're going to want to resize the table. That'll be where we, double the array, the data structure that we're using to hold our data, and then we're going to rehash everything that is in our current hash table into the new array slots, and that should make things a lot nicer. And to do that, we're actually going to need a data structure to hold the data within the class object, and we're going to make that just be an array of sorts equal to the size that we get passed in. I'm doing this wrong because if we resize the hash table, it's actually not going to be equal to self.size equals size. It's going to be self.size equals length of self.data, and this will actually be the size that gets passed in. We could do something like this, where we, I'm just making sure I was recording, where we make sure, well, we could use the built-in Python dictionary here, obviously, but since we're kind of talking about the theory of how a hash table object works, we're going to use this kind of mocked out array. What this actually ends up being is a list that gets initialized with all elements of 0. And the list, you can append objects to it, but if we were in a coding language like C# or Java, you don't get the dynamic list generation like this. You'd have to create an array or make a collection or import a collection or something of that sorts. And in Python, we can kind of mock out using an array using this notation. So I'll go ahead and show you guys how that works. So we'll just print self.data here. For those unfamiliar with it, and then we'll write some testing code just to show you how this constructor is working. and we're going to call this our hash table equals hash table, and we're not going to pass in anything because we'll use the default size. So this will create a class of hash table that holds data in self.data, but we're not actually inserting data or removing it or hashing anything quite yet. We're just creating the basic object and showing that it will print our array when we initialize the hash table. So we'll go ahead and run this and show the output down here. How do we do this? Run Python file in terminal. So you can see here we have an array of 10 elements, all initialized to 0. So that's exactly what we want. So now for the rest of our interface, we want an add method or an insert data. All of the methods will get past the self instance of the class. That's kind of default for Python. And this will be the key, and this will be the value. This allows us to pass in generic keys and assign it any kind of value we want for recollection later on. We'll go ahead and use the PEP8 standard for creating code comments to help document our code a little more. This method inserts data into our hash table. And then we'll tell it the args. This is because with a lot of documentation libraries, it will understand this format defined by PEP8 and print out documentation for you automatically. So you don't have to write all of that in addition to writing the code, which is nice because you end up not repeating yourself. So the key is an arg. This, for our purpose, it'll be a string. The key to insert, and then we have value. And for our purpose, value will be assumed to be a tuple, and this tuple will represent customer data. It doesn't need to be a tuple, it can actually be anything because of the way Python works. But if you use the typing library, I think you can do something like this, and you can force it to be a tuple. Does Python just automatically import typings? But anyways, that's all optional stuff to make your code more defined. For learning purposes, we're just gonna have it be generic, but we're gonna say that we expect it to be a tuple, and this will be a tuple of customer data. And for the insert method, we're just gonna pass for now since we're defining our interface. Other methods that we're gonna want is get. So we'll want to get by key, and for a single line comment, we would just do it inline, get data by key. We probably don't actually need this comment here because get pretty much says exactly what it's going to do. And if you have self-documenting code, you don't need to over comment your code, but we're just going to do it to try and enforce good habits. This will just pass for now. And then we'll want to remove data based on a key. Pass for now. We're not going to over comment just to make this video a little more simpler. And we kind of talked about the purpose of the comments anyways. And then since this is a custom hash table, not an actual Python hash table, which is the whole point of this exercise, we're going to want to do something a little more fancy than just the basic three methods of insert, get, and remove. So we're going to do get, or we'll do key contains, and this will be a substring. And we will document this, look through all the keys and return data as a list that partial matches the substring. So what this could do is, since we're going to be inserting in customer data using our insert method, and the key is going to be an email address, key contains, for instance, could tell us all of our customers that have a gmail.com email address, or all of our customers that have Bob as part of their email address. So this kind of gives us some a deeper way to look at our data more than just a standard get or print out all of the data inside of it. So this gives us search capabilities within the data that's stored in the hash table. And we're gonna pass this for now too. So now that we have our standard interface with the methods that our hash table class will contain, let's think through a little more in depth on what our hash table is gonna do. So to insert into a hash table, you need to generate a hash. To get it and remove it, you also need to regenerate that hash and then use that to be able to delete the things or get them or insert, for instance. So this method, well, you're gonna need common code to all three methods to be able to work with the data in the hash table. So we'll just call that get a hash index. So for instance, this method, if you saw the other video, it will generate the hash, take the modulo based on the size to get the index, and then it will return the index. So this just needs to be called with no parameters. Actually, no, it needs the key. So it'll get passed with the key, and it will return the hash. Actually, inside of this, in the insert, generally you include the return value. So I think you do something like this, and you just say it returns none. You could write more. You could write fancier logic inside of this method if you want. If it fails to insert, or if there's a collision and you don't have collision logic, you can be like, this key already exists, create a new email address, which you usually don't want to enforce the customer to create a new email address. You want your hash table to deal with collisions. For the sake of this video and time, collisions and resizing the hash table is going to be in another video, which is actually something else you're going to want in this interface, is a function that will resize hash table. We don't need to call it resize hash table because since it is a property of the hash table class, if you just call it resize, that pretty much implies that it's going to be working on the hash table. This doesn't need any properties, however, and we are going to pass on this. So now we want to write the implementation code for this. Resize, again, we don't care about. Get hash index, we will take from the previous video. So we have code that creates an index based on a modulo of the size, and we have code in here that creates a hash value of a key that gets passed in. So we're going to copy this fun code here, and we're going to move that into our hash table class. This is pretty much a general theme of software development. You'll write some kind of code, and as you reuse that code more and more, you'll add more abstractions to it. You put it in a class, you add more methods into the class. You create a new class that implements other classes and extends functionality using inheritance, and kind of just the whole iteration cycle of software development. So that's what we're doing here. We're taking code we previously wrote, and then we're rewriting it into something a little more usable. So we'll get rid of the pass. We will return this value. So this is our hash index that gets generated here using the rhash variable, and then taking a modulo based on size table, but size table does not exist in this new code, but self.size does exist. So if we were to resize the hash table, self.size will change, and we will get a new modulo value for our code. So for instance, if we have a string, we'll call it foo, and let's say for some reason foo, the hash of foo ends up being 10. And then we have another string called bar. The hash of bar equals 5. And if we're doing a modulo operator, which is what this is, it kind of just calculates the remainder. And let's say the size of our hash table is 5. 5 modulo 5 equals 1. 10 modulo 5. Did I do that right? No. It's the remainder. So 10 modulo 5 equals 0. and 5 modulo 5 also equals 0. So if we were inserting these into our hash table, foo and bar will both go to the same index value. They'll both try to look at the 0, but that's not necessarily what we want in our toy hash table since we're not dealing with collisions. But if we resize the table and we generate new hash tables, and let's say we modulo this at 10 now, foo 10 modulo 10 still equals 0, but 5 modulo 10 equals 5. So you can see how rehashing the table or resizing the table generates new hashes and gets rid of collisions and spreads out the data across the hash table more randomly, I guess is what you would want to say. But that'll be the next video. So be sure to subscribe to the channel and follow along for the next follow-up if you want to learn more about hash table creation and theory and all that fun stuff. And our previous code had rdata.encode, and we were using rdata.0 as the key, but this hash table method is a little more abstract to kind of handle different types of data that doesn't necessarily have to be a tuple. So we will rename this to just be key.encode hex digest. The main, no, what's the word? The main rule is that whatever you pass in as key has to have a .encode method. So I guess key kind of needs to be a string. So you can do something like key string equals key, well, no, you want to cast it. So that way, if you're using an index as a key, the index will get converted into a string, and then you can do key string.encode. Or if you're passing in an object that has a string method on it, it will get converted into the string, and then that will get generated into a hash as well. So you can actually use objects as keys using this code. That's kind of like an advanced concept that you might not really need to worry about too often. And I think the Python built-in dictionary does that by default. And we're getting this red squiggly line on hashlib. That is because we haven't actually imported it. We'll go ahead and go back and do that. So import hashlib, and now we have access to this from the standard Python library in our code. And for insert, actually, another thing you want to worry about in hash tables, you know, like I mentioned, that multiple things can get put into the same key, is if you are getting data by a key, like let's say you're getting foo, and foo and bar resolve to the same index. So foo could potentially return bar's data. So because of that, you want to store some kind of representation of the key when you're inserting the data. So you could potentially do that by like a tuple where the first value is the key and then the second value is the data. And I think we might actually want to do that. So so we do something like hash data equals key and then value. So we'll use this when we're inserting, so that way we can track the different keys that get put in. And then we're going to want to get the hash index, and we will do that by calling the hash index function that we wrote, and we'll insert the key, and then we'll just store this into our data array, self.data hash index, and this will actually be the hash data that we put in here. So this will allow us to make sure we are only retrieving data if the keys match later in the future. It is really hard to talk and type at the same time when you don't have any scripts written. And I think that's all we need for the insert method. For the get data, we will get the hash index again. And we'll do that by the key. And then if key not equal to self.data hash index, we can go ahead and raise key error. hash key does not exist. So this way, if we try to get foo, which goes to the same data as bar, we don't actually return the bar data instead. So this is kind of some defensive coding, and it allows us to raise exceptions, which will break further execution of the code and kind of force the client to deal with the error that gets raised up. If the key does exist, well, if the key is the same as what's in the hash index, this is actually wrong. So this will return a tuple. So we want to actually compare keys, which we already said earlier, the key is at the 0 index. So we actually want to compare the key to the 0 index. All right, and if it does exist, well, what happens? Actually, so there might be a chance we look up a key and the hash data is still equal to 0, or the hash table data, which means we haven't actually stored anything in it, if you look down here in our terminal. So if the self.data hash index equals 0, and we don't actually do that here, then we also want to throw a hash key does not exist. Yeah, I think that'll work. And we don't need to explicitly say else, because anything that's else will just fall through the key error. So then we can just do return self.data hash index. It might be a little smaller or a little easier to read if we do something like this. Data equals self.data hash index. Key equals, well, we can't use key. So we'll use, we'll call it dk for data key equals data.0. So now we can condense this code, make it a little easier to read by doing something if key does not equal data key, and then if data equals 0. So both of these mean that the hash key did not actually exist. Or else we'll just return the data. And actually we only want to return the actual data. Not the whole tuple that has the key and then the data. So that will cover that case. And this code will be very similar for the deleting, actually. So we'll go ahead and copy this, and we'll put this into our remove function, and we'll modify it to do the removal. Since we are initializing everything that's not data as 0, basically all we want to do is look up that index and set that value to 0 if it does exist. So this is all the same. This is all the same. We could put this in a helper function, but we don't need to, like something like get data or verify key. But if the key does exist, then we just do self.data hash index. And we set this to 0. And then if it returns a none, then we just assume that it worked. All right, so now we have our getter implemented, the insert implemented. We have some private methods indicated by the double underscores in the beginning, which we are using within our methods. These are implemented to get the hash index for our different other public methods. And then we have some test code down here. So let's go ahead and reuse this to insert some data. We will reuse our customer data that we created in the other video. Go ahead and plop this down over here. And to insert, we can see from our IDE that insert takes a key as the first parameter and then a value as the second parameter. So our key for this will just be our data 1 or our data 0, and then the value is just the whole thing of our data. And then we can go ahead and use some print lines to verify that this works. And we'll do this just by calling print a couple times. If we were in some application code, we'd probably want to use a logger. And then we will use the built-in HashTable.data. Which is the property here for, where is it? Data. Okay. And actually, I just realized when we add stuff, we want to increment our number elements so that we can determine if we need to resize or not. So self.num elements plus equals 1. And then here we'll do some logic. If num elements equals self.size times 2, then resize. So this is kind of a reminder that we need to iterate our code even further to go ahead and do the resizing. And we'll also need to check collisions and then change how we're adding data in the future. Again, follow along if you want to see that follow-up next week. Otherwise, this is just kind of the basic interface and class that we'll be using for an internal custom hash table. We'll also implement this key contains method in the next video as well. And if we remove data, we're going to want to decrement the number of elements. So we can do that with the -=1 operator. And for this, we can potentially condense our data so that we're not using as much memory within our application program, and kind of like free up space to do other things if you have a really huge hash table. All right, so we've inserted data, we incremented our internal representation of how many entries are in there. We can show that by actually printing our HashTable.num elements. And we're showing the data, and then we will print our HashTable.get, and then the value here, which is just our data .1. Our data 0 actually, since we're using the email address as the key, since email addresses are assumed to be unique, whereas multiple people can have the same first name. And then just to make our console output a little easier to read, we'll go ahead and add a marker here that this is getting the data. And then we'll also show something about removing it. So remove data. So to do this, we call the remove method. We insert our key that we have been using. We could probably assign this to a local variable to make it easier to keep track of. But we'll just keep using the 0 index data from our data tuple object that we defined up here. I'll also go ahead and put this code in a pastebin so that it's easier for you guys to retrieve and copy and paste into your IDEs and work with this. And then we will print the output of the table here. So our HashTable.data. So we're going to print it again. So this will show a tuple somewhere, and then this should show all zeros. This should be everything we need. We'll go ahead and run this in our terminal here. You can see everything ran successfully. And when we insert the data in our 0 index, we have the tuple, and then the rest are zeros, and we can see num elements equals 1. We could also print num elements at the bottom, and it would probably be 0. And then we can see the output of our getData method, which is the tuple that we defined in our test code. And then after we call remove data, you can see that this gets reset to 0. So this is the basic interface and implementation of a hash table. And given that we created this ourselves, we can add any kind of custom logic and methods that we want to. For instance, the this key contains method. So we'll be implementing that next episode. Definitely check that out. And thanks so far for watching along, and I hope this has been informative. Take care. Bye.